go from there. Does that sound good? All right. And I'm letting my dog out the window right as I say, let's get started and the recording starts. So that's all part of it. Welcome, folks, to Fairwind's Kube Clinic. Today, we're going to be hearing from the folks from CloudTruth on methods to manage your Kubernetes ConfigMaps and secrets data. And let's go ahead and dive in. So first of all, well, Matt, you want to introduce yourself?
Sure. Matt Conway, the co-founder and CTO at CloudTruth. I've been working in the Boston startup scene for the last couple of decades. Before that, I went to MIT for a computer science degree and grew up in Kingston, Jamaica. So now that it's getting cold, I was just telling Kendall that, you know, I didn't like the cold weather, but for some reason I live in Boston. But anyway, Darryl?
Can't win well. Yeah, Darryl, go for it.
Thanks, Darryl Diosmito, solutions engineer here at CloudTruth. Before that, I've been in various other startups, some in the infrastructure as code space, deep into the storage, networking, virtualization background, led the hyperconvergence marketplace at a company called SimpliVity that HPE acquired, and have done tours at HPE, EMC, and really evangelizing virtualization, and now I've made my way into the cloud space.
Okay, wow, I didn't know about the HPE stuff and EMC stuff. Now I have questions, but that'll have to be for another time. My name's Kendall Miller. I'm president here at Fairwinds. Been involved with the company for 6 years and a couple of months, which is a little shocking to say out loud. Been involved in the Kube space for about 5.5 years of that. So we've been heavily focused on Kubernetes, and tell you real quick who Fairwinds is, and then we will turn over the reins to these folks. So, so Fairwinds, we have been, as I mentioned, in business for about 6 years. All we do is Kubernetes, 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 Kubernetes. That's why we do these Kubernetes clinics. And we have a history of doing lots of services. So that's build and maintain Kubernetes infrastructure for people as a result of managing lots and lots of clusters across lots of different kinds of organizations. We have an insight into some of the macro level problems that people tend to run into. We have taken a lot of those things and written open source software in this space to address those problems. And then now we make a SaaS solution that brings together that divide between dev, sec, and ops to make it so that you're deploying things into Kubernetes that your teams can own in a service ownership capacity, that kind of thing. So if your company works with Kubernetes, Fairwinds probably has something relevant to you, a service, an open source tool, or our software. So glad you're here. And well, this is about Fairwinds Insights, which I can maybe touch on later in it, but I want to stop and turn it over to y'all to dive into your talk today about ConfigMaps. And I'll let you go ahead and share screen and dive in.
Right. Still there? Coming through okay?
Yep, looks good.
Perfect. So, yeah, as I mentioned, you know, Matt, with me is Darryl. We both work at CloudTruth, and you know, at CloudTruth, similar to Fairwinds, we're trying to reduce the complexity in things, right? And in our case, we're focused more on, you know, the configuration of the various components across your stack. You know, we have a strong belief that very frequently the big picture is lost when you know, you try and configure things with, you know, the blinders on. So we're trying to give people the tooling to allow them to configure things both at a local level and at a global level, and have that interact and you know, keep you informed as to what's going on in your system. And you know, like all other sort of the big verticals in the stack, every 10 years there's a need for a new set of tools to deal with one of those areas. So things like logging or, you know, configuration, you know, it helps with sort of the clean sweep it seems across our industry that happens every 10 years. And the most recent such sweep is with respect to Kubernetes. So it makes sense that we apply our capabilities there as well. So speak a little bit about the challenges of configurations. specifically for this talk, we're looking more at application configuration, though, you can always step that back out to infrastructure as needed or to share data between the two different layers in your stack. So, that, as we all know, there's many ways to configure the bits of your system. And there are many ways to configure Kubernetes to run your system. As a result, not only are there a lot of, as your application scales, you have a lot of application pieces to configure, but you may also need to configure things that are not directly a part of your application, but are responsible for making your application run. So, things like, I guess you could think of Nginx as one of those, since a lot of people use Nginx as an ingress layer in Kubernetes, but you may be depending on a bunch of other containers too that may not be core to your business logic, but help support your application in some way. So, there's a lot of configuration that needs to go on. And there's a lot of configuration that needs to be coordinated across your pieces. So why ConfigMaps? Did I get that right? No, I missed one. This paging doesn't always seem to happen right away. I'm not quite sure. There we go. I keep that on. Did it again. Anyway, so
can't win them all. Half of technology is just fighting with Zoom or PowerPoint. So it's
like
okay.
if I hit down, it doesn't change the page, but then if I do it again, it goes to for some reason. So I'll have to. I don't skip anything. When you're configuring your application, there's a progression that many people go through, right? Typically, if you're just starting off with a prototype or something really simple, you may not have any configuration at all. You may just hard code that directly into your application. Maybe go the extra step and have a constant in your code or something that's hard coded to a value. But once you're moving past sort of the initial, let me just see if I can get this working state. Then you start to want to make your deliverables more reusable, right? So the way you typically do that is you extract out the configuration that you want to be able to change into a form that's easy for someone else to change. That's typically a configuration file. So in the Kubernetes world, it's probably YAML, but might be JSON. Unless you're writing Java, then it's probably properties, maybe XML. But there's a number of ways you can extract out the various configuration drivers into an external file. And then, the progression after that is, all right, now I have this, this container, this image that I want to be able to configure in different ways, but I don't have to build it multiple times. How do I deal with that? And that's typically done by setting environment variables, when your container runs. So one of the most common methods for achieving that is through use of a .env configuration file. So it kind of combines both the configuration file from step number 2 with having environment variables be able to override them. So, in your .env file, you'd list out all of the various configuration items you might want to set, probably with a default value. So typically you'd set it up that way so that in local development, things just work without you having to set anything different. And then, if you set those values in the environment, then it will override the value in the .env file. So, frequently in your container specs, be it in like Docker or Kubernetes, you can set environment variables, and those would then override those .env files. There is no shortage of ways you can configure things. A couple other ways for Kubernetes would be, for example, CLI arguments. So in your container startups, you may parameterize it with different arguments. And you could even go so far as to have code inside of your application that hits a service and pulls configuration that way. And then what this talks about is config maps and secrets, right? So that's the Kubernetes approved way of dealing with this configuration so that you can have this reusable image runtime. So why config maps? If you go to the Kubernetes website, it's basically what it's saying is you should use config map to decouple your runtime from the configuration that drives it, so that you can reuse that runtime in different scenarios. typically that's, especially for internal things, it's usually along the lines of, run it in dev versus staging versus production. In an ideal world, you like to use the same deliverable in staging and production, because you want to test it in staging to make sure it works before pushing it to production. And rebuilding it for production is kind of counter to you validating that it actually just worked in staging, right? But if you can just change the configuration, yes, the configuration could break it as well, but at least you're reducing the number of variables for breakage. And then
could you touch say one more thing about that? Like, you're talking about in the ideal world, you have this config map that makes it easy so that it's decoupled from environment specific configuration. Like that explains it a little bit, but give an example of the anti-pattern of that. Like what is a company doing when they're not using a config map that is running into this problem? They're writing environment specific everything hard coded into the application. Like, what does that look like?
Yeah, so anywhere further up this list you go, right? If you don't have a way to just tweak configuration without rebuilding your image, then you don't have a reusable image, right? It's kind of like if you want an analogy back to compile software, right? You don't make a different compiled executable for each user. You compile the executable and it can read some configuration file and configure itself. In the Kubernetes world, the user, I guess you can think of the user as the system you're running in Kubernetes, right? So that system needs to be able to specify the configuration relevant to it, staging versus production, without having to depend on a different image. So yeah, I've seen it very frequently where people completely rebuild their system between staging and production, and I think that's an anti-pattern, right? You want as much to stay the same as possible between staging and production, so that if it's working in staging, you have a high success rate of moving it to production because you're not changing anything. Obviously, in the real world, you can't have everything be identical between staging and production. You want to, maybe you're running on a different domain name, but most of the things that are different between the two, you should strive to make that be configuration level changes, not compile level changes. And it also makes, when you do stuff like that, it makes promotion between the different environments a lot easier, right? If you really wanted to absolutely ensure that nothing breaks between staging and production, really the only way to deal with that is to have sort of a canary deploy, right? You deploy a small portion.
Sure.
Not everybody's set up to do that. It's not easy to do. I guess blue-green deploys, you can kind of accomplish that as well, as long as your blue or your green is not accessible to the public until you've vetted it. So yeah, there's other sort of techniques you can use to preserve, to keep things working through your deploy lifecycle. So yeah, ConfigMaps. It's the Kubernetes approved way for allowing you to reuse your components across different environments, or even across different users, right? So, obviously for internal things you're building internal for your application, it's typically just an environmental thing that you're reusing it across, though it could be, different usages of the same image for different portions of your stack. So maybe you have a service that you're running multiple copies of, and each copy is slightly different. Then you could reuse the same image, but start up, service foo versus service bar with a different configuration. And then, for sort of third party and open source components, so something like an Nginx, you want to be able to use Nginx across your entire user base, and everybody has a different configuration. So it makes even more sense there that you can, use the same Nginx image that's released by its maintainers, but just push in a different configuration. So ConfigMaps are, one way to achieve that. I don't know if they're the most popular or not, but they're sort of the most embraced by the core Kubernetes platform. So one other sort of, piece of information that not everybody realizes is that secrets are just config maps in the Kubernetes world. They're slightly different. You can kind of say they're a little more of a superset of config map than anything else. So because they have all the same capabilities, and they have similar goals, right? It's, as opposed to just configuration, this is secret configuration that you may not want all eyes to see, but it's the same kind of, you're trying to achieve the same behavior where you have a single image that you're using in different ways by giving it different secrets. So maybe dev has a different API token from staging or production. So that's the main difference between secret and config map. One thing to note, it's not particularly secure. The values, the data are obfuscated slightly with base 64 just to prevent somebody looking over your shoulder and seeing the secret while you're poking around in your console. But anybody can unencode that without having a key or anything. And the expectation there, at least with the vanilla secret in Kubernetes, is that you restrict access to the secrets by using RBAC. So if only component X needs to read the secret, then only component X should have read access to that secret resource in Kubernetes. Now, there are other ways to keep things secret, right? In your application, you can call out to a third-party service to get your secrets, right? Vault being the prototypical example there, CloudTruth as well. But yeah, it's if you're trying to use the secret resource, using RBAC to protect it, so only the right parties can see it is the path that you follow. So how do you consume config maps? I've got this image, I'm deploying a pod or a deployment, and I want it to get its config from a config map. So first off, config maps are flat dictionaries. So you have key value pairs, but you can't have nested key value pairs. So a key can have a value, which is a string, but it can't have a value, which is another set of key value pairs. You can work against the config map using the Kubernetes API and kubectl. It's just another resource, and as long as you know how to form them within the YAML, then you can push them into the system that way. And they can be mounted to a pod. So basically, if you think you think of this bunch of key value pairs, that's the same as like your environment, right, for your process. It's just a bunch of key value pairs. So when you have a config map, you can tell the pod, hey, make everything in this config map be an environment variable for the the process when it starts up. That's the most common way of using it, especially if you're doing something like .envs. It makes it a lot easier to map the config map to what you had in your .env file to get it in there. And one caveat with using it this way, though, that they're static for the life of the pod. So if you change the values of the keys and values in the config map, you don't see those in the pod until you restart it or redeploy it or something like that. The other way you can use config maps with your pod is as a volume mount. So rather than putting them as environment variables, each of those key value pairs become files in a file system that you're mounting to the pod. So each key becomes the file name, and the value becomes the contents of that file. Unlike the environment variable form, if you change a config map, the files will be updated on the file system in the running pod. So that's sort of the easiest way to be able to get updates without doing a restart, though it would then be up to you to actually notice that the file changed and reload the new value. Now, and the frequency may not be quick enough for you. I think it's configurable. I can't remember the exact setting you tweak in Kubernetes, but there's some polling frequency in Kubernetes that determines when it sees the config map change, how long it takes before it creates the new file in the volume with the new contents. Finally, since there are these two different ways of mount into a pod, a lot of people want to be able to automate how, especially when you're using environment variables, to automate sort of the life cycle of the pod whenever you change configuration. And there's a few ways you can do that, but one of the sort of best practices, I dare say, is you can name your with a checksum of their contents, and then reference that checksum name with your pod, so that when your config map changes, it causes the config map name to change, which causes the pod descriptor to change, which forces a redeploy. So if you have tooling that can manage that flow of information from when a config map changes to trigger those name changes all the way up the stack, then you can synchronize the life cycles that way. So at this point, hand it off to Darryl, and he'll walk through some of the common ways of using config maps. Starting all the way at the bare metal, showing you what the config map file looks like, and then working up different techniques for managing your config maps within your system.
You're not going to start, Darryl, with the anti-pattern of here's how to not do it without a config map? I'm just kidding. I'm sorry.
Yeah.
Keep going.
No, we're trying to move forward here, Kendall, right? Always moving forward.
Excellent, excellent. Forward is good. Forward is good.
Right, thanks, Matt. So we're going to start really from the ground floor, right? So everybody is at a different place in their journey on their journey to Kubernetes, and when we see these polls, it says 40–50% people are already in production, and many users are just getting started. So we're going to progress rather quickly from here's a base config map, here's how you apply it, all the way up to dynamically creating these config maps and updating them with a Kubernetes operator. So our first step is just a basic YAML that is a config map in Kubernetes sense that has a kind of config map. It has some metadata with the name. It also has some data. This is a key value pair. We're going to see it creates just a key and a value, and then some file-like keys and values. So applying this config map, we use the kubectl command to apply this directly locally. We'll see it's created. Everything is running locally in my Minikube cluster, and I have a dashboard. So we're going to be bouncing back and forth through my editor and the dashboard here to show examples of what's going on. So this config map got created in the default namespace based on the key value pairs and the file layout structure that we had in that basic YAML. This can be edited directly right through the dashboard or through your local editor using kubectl itself. And now the interesting thing is when we've given this presentation or demo a few times, we never really expect to say people are actually editing their config maps locally and going into prod and dev. But to our surprise, there have been a couple that users actually end up editing files locally. The danger with that is there's no version control, there's no tracking of revisions. So things can kind of get out of sort quickly if you're live editing even your development or staging environments, never mind production.
Which I'd just like to stop real quick, Darryl, and say a lot of people do. Like, that's the wrong thing to do. But that's, if you come from a world where, the way you solve the problem is you SSH into a box and you fix the thing, you're like, oh, well, production's running, I'll just log in and tweak some things, right? So, I understand how people got there, but it is a very common pattern. It's the wrong way to do it, but keep going.
Yeah, and that common pattern is kind of what we're trying to break out of the mold of the next steps on how there's other ways to do this, right? So that being the very basic one to try to avoid. The second we're going to go into is a little bit of this tool called Kustomize. People may have heard it. People are using it different ways. We're going to use it right now to automatically generate a config map. So I have a customization YAML, and in this YAML, I've commented a few things out, but we'll walk through those as well. So Kustomize itself has the concept of a config map generator with a provided name, and it's going to use a file that's local to my environment called game.properties. So we're going to do this in two different ways, files and environment variables. I'm going to show you the implications of that to a deployed pod. So with Kustomize, it's part of the kubectl command. I'm going to run kubectl apply. I'm going to pass it to Kustomize, and I'm going to pull everything in this directory, which is this dot. It says it's created. Kustomize gives you a hash for the version that gets created. Bouncing back to our config maps, we'll see we have a Kustomize created config map. Still using this key value pair with the game properties. So that's great, but let's take it a step further. With this Kustomize, we also are able to apply resources for a deployment type. This deployment type is a kind deployment. It's going to deploy an application, which is an Nginx pod, and mount this created config map called Kustomize config map directly to this pod as a volume. So now this is an example of one command that's going to get you a config map, a pod, and that config map mounted to that pod to use the configuration that we're applying and defining in that config map. Bouncing back to our dashboard, our config map is recreated. We'll go to our pods. One moment. Probably should save that file first as we make edits to it. That's always helpful, right? Now let's reapply that. And now you can see it's created the config map and the deployment type. My Nginx pod. This right here allows you to execute into that running pod. We'll take a look at its config. And you can see that we have a game properties file, and the contents of that file are our key value pairs. So what we just did was apply this customization YAML, do a deployment, which pulled down an Nginx pod, and mounted this config map as a file type, game properties. What that looks like in the pod is a config file that has a game properties file in it with your key value pairs. Now I'm going to clean that up and show you another way to use Kustomize. Rather than mounting our config map as a file, we can pass it as an environment variable. I also have this local env file here, which has our key value pairs. Now with just this one change, we can apply our Kustomize, config map and deployment created. We'll exec into our pod again, which is just our simple Nginx pod. And now when we go into config, instead of a flat file, each one of our key value pairs becomes its own individual unique file. Now, two different ways of going about it, and this is how you can tailor your applications. Perhaps you have an application that's just sourcing that one file and pulling application data specific from that file, or you can grab each individual key value pair individually within this volume mount called config. So that's a little bit on Kustomize. People are using Kustomize in various different ways. There's a lot of ways to use it, but this is just, again, just a starting point and just some basics on config map management with these various tools. So now we're going to get into a world of multiple environments, right? A lot of organizations have the concept of development, production, staging, and how you manage this configuration with differing values across those environments. So one approach that we've seen people use is use GitHub as a source of truth. And you can find some success doing that. So what we have here is a GitHub repo, and it has our ConfigMaps inside this game demo repository. I'm going to keep using this game properties file that we've been referencing that has our key value pairs. Well, inside this repository, I'm using a branching strategy for my development, production, and staging environments. If we switch to our production environment, we see that our game starts off with a player lives of 30, allows secret code lives of 30, base lives of 3, and enemy cheat codes of false. But our development environment for this game starts you off with 100 lives, 1,000 cheat code lives, and allows enemies to cheat. We can now apply this branching strategy in GitHub to apply our config maps for each one of these separate environments directly out of our repo. So if I look at our branches here, which I've already been working on in this repo, I'm going to switch over to my development environment. And we're going to use a command that we've been using, but we're going to create a config map directly from the game properties and the UI properties files within this repo. So this is saying create a config map game demo from both of those properties files from my development branch. Bounce back over to our Kubernetes dashboard. We'll look at our config map and look at our game demo. We see that now we have a config map that has our 100, 1000, and true. Say we want to roll this out and deploy our production config map for our game. We're going to check out our production environment. What this is going to do is going to pull those new values in. And I'm going to replace this config map by outputting YAML from this config map and directly running it into the kubectl replace command. Now our config map is updated with our production values. So this allows you version control, it allows you source control, commits, branching. But some of the difficulties with it are, how do I track those changes between these different environments? This is a very simple example with one directory and just a few properties files that we're creating and turning into config maps. But I think you could see as our applications and microservices grow, identifying the changes between these environments, it gets very difficult. We could do a simple git diff between our two environments, but this could lead to errors that you may have values within production that are not necessarily what you want them to be. And this could lead to outages, as we've seen just recently enough with our latest Facebook outage from, what was that, last week? All the Snapchats and the Facebooks. So let's take a second now and think about what if there's some other tools beside GitHub that can layer some value on top of this configuration management infrastructure that we're dealing with here, that can provide some more clarity into our organization's environments.
Are you going to say Subversion? You're going to say Subversion, aren't you, Darryl?
I'm not going to say Subversion.
I thought I knew it was coming. I was all excited.
No, now is when we start. Now is when we start talking a little bit about CloudTruth and what we're bringing to the table in terms of this types of configuration management. So popping over to the CloudTruth UI, I have a project set up called ConfigMap that has a lot of the values that we've been talking about, that from that base YAML all the way to GitHub through the Kustomize and now in CloudTruth. And what we could do here is take this same kubectl command we've been using and apply it. But inside here, we're going to put CloudTruth, our CloudTruth CLI, and pump in a production value directly from CloudTruth itself. And we're going to create a config map in our default namespace, and it automatically gets created with our values, which is great. You're like, okay, well, that's the same thing you've been doing for the past 10 minutes. What's the difference? Some of the things that we've done here is allow you to take this data and prevent you from repeating yourself over and over again in branches or buried into individual branches in GitHub. We allow you to take that data, transform it into templates. This template just happens to be a config map, which I pulled and created right in the kubectl apply, and layer it into different environments. So we've taken the concept of environments, projects, and parameters, and allow you very easy ways to cross-section this data. So I have my development, production, and staging, but say I want to add a new environment built off dev, I can create a dev one. Let's take a look at one of these parameters, this lives parameter. If I look at it, the default is 3. My development environment has 100. But what's unique about this is that the value gets inherited across all my environments. So I don't have to worry about getting a base value in each one of my branches. This CloudTruth tool is automatically doing that for you and allows you to provide overrides for each environment. We have compare functionality, which is somewhat like a diff, but visually and through the CLI allows you to easily select your multiple environments, see the values, and get the differences directly across them. So that way you're not searching through these various branches. We also have history and tagging, where you can tag an environment and get a stable version of it. And if you're asking yourself what was the difference between a production branch or a staging branch between now and a specific point in time, you can go back and select a specific date or a tag, hit apply, and we'll show you the values of the current as well as what they were at the time of that specific tag. All right, so let's get in a little bit now what we can do with this and how we can apply this to some of our applications. Matt hinted at this in the beginning with how config maps can be mounted as environment variables or a volume. Let's take a look at a practical example of that. So we're going to continue to use CloudTruth for this, although I could use GitHub, but I have a project called Flask Map, which has environment variables built for a Flask application. Now, to take it way back to do it the wrong way, you could build this Flask application in Python and just bury all this configuration data within the application, run that container, and you're going to get the same thing every time when you run that container. The problem is when you want to reuse that container for other things and pass configuration data into it, you're kind of stuck. So building containers and microservices that allow for configuration via config maps and secrets really gives you that portability down the line. So what I just did there is I applied, and let me just open up. I'm going to show you a little bit of YAML. I applied this deployment, this Kubernetes kind that's a deployment with, oh, I'm sorry. I applied a config map from my CloudTruth template, going back to my dashboard. I created this Flask map template that will now provide data for our pod deployment. And what I'll do is I will apply this Flask YAML that creates a service in this demo application, pulling in this config map as environment variables. So since this application has a service, I'm going to start up this Flask service here, browse to the URL. And what this is it's a Flask application that just pulls up a little web browser and a little image. I pulled it using production data from my production config map. But now if I want to modify this, I can change the config map data directly from a Kubernetes apply command. So I'm going to apply a new config map, but this time I'm going to pull the staging environment. Let's take a look at our config map. What that did was it changed the image. It changed our message from production to staging. Now, since this is mounted as an environment variable, to pick up those changes, we need to do a rolling restart of this pod. In order to do that, we'll give it the command kubectl rollout restart deployment. So there'll be no downtime involved. What this command is telling us to do is to spin up another pod. And then once that one's spun up and it passes all of its liveliness probes and health checks, we'll spin down the old pod. Then when we come look at our image, we get our new message and we get our new image. If we were to exec into this pod, and we do an export, we'll see that since we've passed this in as an environment config map, mounted it as an environment, that our environment variables show up directly within the pod. When we mount it as a volume, it's going to look like it did before and have key value pairs as a file with inside a volume mount. So what I'll do is I'm going to clean up that pod deployment. And I'm going to show you an example of what that looks like as a volume and demonstrate how a config map mounted as a volume can automatically get those changes. So I'll apply a config map from CloudTruth again, this time pulling in the production environment. That's going to update our Flask map config map back to our production values, configure management for production, pulling in our original image. And this time, I'm going to apply a YAML that has this config map mounted as a volume. I'm going to restart my service. And now while this looks the same, the underlying difference is that the pod is mounted as a volume. So we'll take that same approach. We'll change our config map using our staging environment. Popping back in the dashboard, we've already picked up those changes to the config map. And that timeout that Matt was talking about now, it's about 60 seconds. So when you hit it, the pods are going to restart based on where it is in that refresh cycle. So while that's happening, we'll take a look back, we'll exec back into this pod. We'll take a look at the way it's laid out. Right? I chose to mount my volume in etc config. And now, as opposed to having those environment variables, we have key value pairs with the key and the value within these images, and my application is actually reading from these files. And now my application is updated without having to do a rollout restart. So now, while that may have seemed like we got into the weeds a little bit with pods and deployments and config maps and volumes and environment variables, the takeaway there is there's multiple ways to mount config maps. One is environment variables. That requires a rolling restart to pick up those changes. Another is a volume mount, which will automatically pick up changes based on the pod's refresh cycle. And you can easily pull from different environments: production, staging, development, dev 1, dev 2, dev 3, pump those values in your config maps. And you can do that with CloudTruth. You could do that with GitHub. But with CloudTruth, you get the extra benefit of having that, monitoring layer. All right, the last thing we're going to go into now is what you just saw was a lot of manual work that went into that. A lot of Kubernetes commands, a lot of jumping back to the dashboard. We've built an operator that hooks into our CloudTruth projects that will automatically create, update, and provide config maps and secrets to a Kubernetes cluster in any namespace. So it's highly configurable. I have it installed in my Minikube cluster now in a dedicated namespace called demo kubetruth, because that's what we call this operator. And what it did on installation was create all of these config maps and secrets based on the project hierarchy I built out in CloudTruth. So, for example, we can look at this demo project. It has a secret. We can view it. This base 64 decodes the secret. We also have config maps with a number of parameters inside that were all dynamically generated, created, and updated. To give you an example of this, we can create a new CloudTruth project. Now, and within this project, I'll create a few new parameters. So that was just a basic parameter. And now I'm going to create a secret. A secret within CloudTruth is actually stored in a dedicated vault. We're running dedicated vault as a service behind the scenes. Whenever you sign up for a CloudTruth free trial or a paid subscription, every organization gets its own dedicated vault. So just by flagging this parameter as a secret, that's what's happening. So I created a CloudTruth project, K8s demo. I created a parameter and a secret. Now, when we come back into our Kubernetes dashboard, you'll see that we have a config map called K8s demo. In there, I have my one parameter. If we look at secrets, K8s demo, we have our demo secret and the secret value. So the magic there is that it's automatically always being synced with CloudTruth to provide you those automatic updates. This operator is also not just giving you config maps and secrets. We also have the capabilities to do deployments. So looking at this namespace, we have a number of pods. For example, this Nginx and this Flash app that were deployed at installation time of this operator. Based on projects in CloudTruth, we've created templates that look like a deployment type, or that I should say that are a deployment type, and automatically get deployed. And the nice thing is that you can control these deployments within CloudTruth as well. So within this CloudTruth project, first let me just start up this service for Nginx. So I have Nginx pod that's running at version 120.01. If I go to this CloudTruth project that deployed this, and I change this image version to 1.2.1, the operator is going to pick up that change because it's monitoring this project and automatically redeploy this pod with the new Nginx version. You can see that we're already spinning one down, spinning one up. And now Nginx is at a new version. So Kendall, I've been talking for a while. We've gone through those 5 different methods. I think we're almost out of our allotted time. So if you want to take questions.
Yeah, so first of all, folks, there is that Q&A down in the bottom. If you want to type in question, if you have any questions about this demo, if you have any questions about ConfigMaps and Kubernetes in general, feel free to drop something into the Q&A or into the chat. The one question that I want to ask here that we've got is, what's the advantage of decoupling the configuration from my code or the deployment?
Hey, Kendall. Yeah, great question, Matt here. So, there's multiple reasons why you might want to do that. Sort of the most obvious for code is it can be difficult to see your changes holistically across multiple environments and multiple projects if your configuration is scattered across multiple repositories, say, right? So you can certainly manage the configuration for each of your components and your system as a whole in GitHub, but that requires people that are kind of tracking down problems, doing forensics, or just want to make a change and aren't quite sure where to make that change. They kind of have to dig around quite a bit to figure out where to do that. Another reason you might want to do that is the person responsible for changing configuration may not be the person responsible for doing deployments, right? And as a result, I'm sure most people in the ops world have run into the scenario where, dev wants to make a config change, but they don't want to run Terraform, or they don't want to figure out how to use the tools you use day in, day out to get stuff into the cluster. So if you can set up automation that will manage that process, so they can use a simple interface to make a simple change, and it will just propagate to the right place with full tracking and audit logging and that kind of stuff, or even approval levels of approval. That saves everybody time all around. So that's a good reason to want to do.
Which, like historically, that's the reason to not change something manually that way, is because then you don't have the audit logs, so you don't have the tracking. And what CloudTruth is making possible is for that to all be tracked all the time, no matter how that change is being made, right? Which is the significance there.
Exactly.
Great. Well, it doesn't look like we have other questions coming through right now. So we'll, for the sake of time, let me see. I think I've got one more thing just to pull up. If, yeah, thank you. I'll share my screen as a wrap up here. So, Fairwinds has a Kubernetes best practices white paper. Go check out. I'm sure that the CloudTruth folks would love to have you get in touch with them and have a conversation about what they're doing and how CloudTruth might be beneficial to you in managing configuration and keeping you from having all the problems that all the ops people are always running into, and or dev people, I guess is the case may be in this situation. But I just want to say thank you to Darryl and Matt. Thanks for showing up and giving us that talk, and I really appreciate it. Yeah, have a great day. And yes, we will be sending out slides afterwards. Somebody asked, and we'll make sure that you get a recording and slides. Thanks so much.